Hi everyone. Great AI results start with great context, but manually collecting data about each and every client is incredibly tedious and time-consuming. Have you tried dropping a link to ChatGPT, asking it to retrieve the needed information? Well, quite often it misses the point, isn't it? It would be pretty cool if we could get the context about our company or our clients' mission, vision, competitive advantage, products or target audience, and even the key problems all within seconds. That's why today I wanted to show you how you can quickly build an app that will gather the context of your client or your company from a single URL. Just leave the company address, and in a few seconds your AI agent will use FireCrawl to scrape the website. We'll store the data in a Pinecone vector database, and we'll use the context from the company website in order to provide key insights about your client or your company. In the age of LLMs, context is the key, and today we're going to make the context easy. Let's jump right in. And just before we start, let's actually see how it actually works. So first of all, what we need to do, we need to provide the link or the URL address of the website we're looking to scrape. So in my case, I'm going to be using my own website, and now I need to tell how deep we want to go. So number of pages to scrape, and let's say we're talking about, let's say 15 pages to scrape. So now we hit submit and the following process happened. So let's actually see what the final result is. Alright, so once the process is done, we can go to our FireCrawl final data. Let's actually reload that and let's see what we got. So we only inserted the URL, and what we got back is basically the company foundation, mission and vision of the company. So specializes in harnessing the power of AI and blah, blah, blah. Tone of voice, the company's tone of voice, product and solution, the problem statement, product description, customer insights, target audience profiles, customer pains, market landscape, market and sales approach, brand and communication. Basically, it's a short write-up. I think it's about how many words? Let's actually see. It is about 537 words, so it's kind of A4 write-up or so about each and every client and company we're going to analyze. And it gives me a pretty good understanding what the company is working with, what is their kind of target audience, what are they doing, what's their problem statement they're solving, etc. This could be really neat if you're reaching out to a larger audience, if you're reaching out to your clients, or you're prepared for client meetings, or you just want to provide more context about your own company and you don't know where to start. So let's actually see how we can get that and how the whole process works. And it all starts with the form submission, which is pretty basic. So we go with we ask for a text input, basically the URL of the website, and then we ask for how many pages we need to crawl. So later on, we're going to be using another tool called FireCrawl that is going to scrape the content from any website. And this is basically showing how many pages we're going deep with, because our websites can be quite large, which might have like hundreds of different pages. So to make sure we don't go too deep, because sometimes that's not really necessary, we might just scrape, 10 or 15 or 20 pages, and that will be just enough. So here I just go with 10. I think in my example, I went with 15, which is like totally fine. So the next thing we're actually using here is called FireCrawl. So in order to use FireCrawl, you can Google it, and it's actually going to be firecrawl.dev. And then you basically log in. There is a dashboard like this that you can later on explore what is available here. And in the playground, you can actually play with different tools that they have. So you can either scrape a single web page, basically get the content from a single page. You just need to pass the URL. But if you're using the crawl feature, it will actually scrape the content from each and every page on your web page. So that's pretty cool. You have a head URL that you're going to use, the head domain that you're going to use, and all the pages that go after that will be crawled or scraped together with the main page. And then we get the map. The map is basically will show you the map of your kind of domain and subdomain pages that you have on your website. And then you can have also the search. So what we are going to be using here is really the crawl. So you can actually play with this model in the playground, but if you want to use it for production for your application, so for this particular example, we're going to be using these two. So we're going to be using the API call to crawl website. Basically, this thing actually is a post request. Basically, it launches the process. So it starts the kind of the scraping. And basically, this one will actually retrieve the results for us. So if we go back to our N10 scenario, so what I have here is basically a URL that we need to pass for the API call. And then we have the two headers, the content type, and basically authorization. And here goes your API key. So in order to get your API key, you actually go to API keys, and then you will need to create a new one and copy paste there. Just make sure there is like a space after the bearer, otherwise it's not going to work, and I will erase my API key after this video for sure. So then you go with the send body request, and then you have to select JSON using JSON. And here we have a few things. So one of them is actually URL, the other one is limit, and some scrape options. So these ones we're going to leave unchanged, but what we're interested is the URL address of the web page we're looking to scrape, and the other one is limit. So how deep we actually going to go. The URL address is basically taking from our form that was submitted on the previous node, and here you can see it's basically here, that's the URL address, and the limit of the pages is basically the second question we asked, about 15 pages, right? Actually, you don't have control which pages it actually going to scrape, so it's gonna just go and scrape like 15 pages, like the first 15 pages it finds, so you don't really have control over that. But I think if you say 15 is most of the cases going to be enough to scrape the main data that you actually need. So the first thing is actually scraping the data, and the second one is actually checking the status. So if we go back to our API documents, you can actually see in order to check the crawl status, we have another API call to make. So we got, now it's going to be a get response, and we have another URL to call. So that's why, and by the way, the only different thing is going to be the session ID that we're going to pass. So let's get back to this one. So now we have another API call. Now it's a get response, but what is important here, we have to insert the unique ID. Basically, that's the ID of the scraping session that we just launched previously. Well, the problem with this one, it actually has pretty much the same structure. Otherwise, the two headers, content type, and the API token that you have. Nothing really much else. But it's really important here because the scraping actually takes time. Think about scraping like 100 pages. This might take like half an hour or so. So that's why I have here a custom module, which is going to which is going this direction. And here, basically what is going to happen, we're going to use this API call to call what is the current status of the scraping process. And if the current status is completed, then we actually go further down the scenario. If it is not completed, it is anything else, and it can be scraping, it can be canceled, or it can be like error or something. And then it basically goes to the wait block, which essentially what it does is actually waits for 15 seconds, and this time is needed for the scraper to actually finalize its work. And if this is not finalized, so basically after 15 seconds it calls and checks the status again. If it's completed, then we go further down the scenario. If it's not, we wait another 15 seconds. And as you can see here, we actually needed to wait for like 3 times about 15 seconds. So it's about more than 45 seconds we actually waited until this kind of things have been passed through. So again, if you have like 100 pages, this might actually loop for much longer. You might actually delay the timing, like not 15 seconds, but like 20 or 30 seconds, whatever. Doesn't really change much. I think you have a limit on the API calls. The API calls to the FireCrawl is the credit base, so each API call like just 1 credit, I guess. I might be mistaken on this one because you're actually not doing any scraping here, you're just checking the status, so you might check that. But basically, yeah, this thing is looping until it's done, basically. And then it goes to spill out, and basically the reason I wanted to spill out this thing is I'm gonna use the data here. So because if you can see, we have got different data items, and this all comes as a single array. So I will want to iterate over each array item, and that's why I need to spill out the thing. So now instead of like one item that is coming right here, we will be having 15 items. So those 15 items sort of like 15 pages, because later on I'm going to be creating custom documents for those 15 pages. So that's what's going to happen in the next node. So I'm going to create Google Documents. I have a separate folder for that. So I've created like FireCrawl folder where I use this ID. And if I go right here, I go Google Docs account. Basically, you need to sign in with your you need to authorize with your credentials for your Google account, and then you basically hit the quick create. And here for the folder ID, I use this folder ID that I just showed you, and you create each of the file with the respective name. So for the respective name of my files, I've actually used the source URL so that you can kind of distinguish that each file basically will be the information scraped from a single page. So once this is going to happen, we have created the files, but there is no information in the file. So the next one is going to be update the documents. So that's why in the same document that we just created, we set the same ID, we insert the markdown of each of the spilled file. So basically here we've got all the content that we've scraped from the web page that we're going to insert into the document. Why, you may ask, why do we need to do this with the documents? Well, because later on we're going to use the Pinecone vector store. And the problem with the Pinecone vector store, if we would just pass, the information from FireCrawl, for example, the problem would be that we will get many other metadata settings that we don't actually need. And in Pinecone, it will actually use that metadata to store in the vector database, and it will be very misleading for a RAG system to have some irrelevant data in the database. And that's why we want to get rid of any data that we don't need, and that's why we're going to submit the binary data to the Pinecone vector store instead of like the JSON data that includes basically all the metadata that we don't need. So once we updated the docs, we're gonna download all the files, and again, to download all the files, we'll use exactly the same ID, and those files will be already updated with the content. So once we download these files, we can upload these files to our Pinecone vector store. So what is Pinecone vector store? It's basically it's a website that allows you to store your knowledge base or store your data in a vector database. And the reason we need that, because our AI agent will be able to retrieve that data by just simply prompting it. So that's why we're going to use the Pinecone. And for the Pinecone, we actually log into our account, and here we need to create an index. I've already created an index. If you go to create an index, you need to give it a name, for example, website data, or something like this, and then you have to pre-select different models that you want to use. Again, it's up to you what to select the dimensions, metrics, and I'm not going to go into many more details about this one. Basically, you have different options here. So I've already created the index for me, and basically it looks like this. And for the model, for the embedding model, I'm actually using the text embedding 3 small model by OpenAI. So here, what we actually are doing, in order to connect to your Pinecone account, what you need to do, you will need to go to API keys, and here you will have your key. So basically, you can create a new one. You can't really change the existing one, so you'll need to create a new one. And basically, you will need to insert the API key right here. That's pretty it. And then we go to insert the documents. From the list here, you will be able to choose your index from the Pinecone database. I have just one, so it's a website. I don't have the embedding batch size, and I have Pinecone namespace. So that's going to be a new namespace created in order to store all my data that I'm going to just create right now in a separate sort of namespace, so that I can quickly get to that. Because in your index here, you can be saving a lot of different data, but you can split those data by different namespaces. So you can have like namespace for website data, for example, like I do have right here. Okay, so that's one thing. Another thing, we need to connect to our model. And what is very important is that you connect to the same model that is on your Pinecone database. So here, for example, I have text embedding 3 small. So I need to make sure I select the same model right here. Otherwise, there will be a mistake. Also, what is more important is the dimensions. Just because by standard, the dimensions for this model is actually 1536, you have to specifically prompt it that is 512, just because in my original index that I've created, the dimension is 512. This is quite important actually. So and the last thing is, so default data loader. Here we actually are passing not the JSON data, we're passing the binary data, and here we need to click load all input data in the docx format. That's because I've just created in the Google Docs and I'm passing it right here. And the last thing is basically recursive character text splitter. This is basically saying by how much we're gonna split the text. So here we are saying about chunk size about 1,000. And if you select recursive character splitter, because you have different options here, you can go with like character text splitter or token splitter. Recursive character text splitter, it will actually split it by the meaning. So it's not like exactly 1,000 characters like it's going to be like with token splitter. It is actually going to be split by meaning. So if there is like, less than 1,000, but the thought is actually finished, is gonna finalize here, and it will take the next chunk. So basically, the whole text that we're gonna pass is going to be split in different chunks. For example, one page can be split like in 7 chunks by approximately, if there are, let's say, 7,000 characters, is going to be approximately 7 chunks of the files, each containing like 1,000 characters. And whenever we need that information, our AI agent will be able to retrieve exactly the needed chunks, not the whole file, because that's going to be just a lot of data. And the more data our AI assistants are having, the more they tend to hallucinate. So we want to pass exactly the right information it needs. And that's why we'll be able to retrieve exactly the needed chunks of the file as an additional context for our AI assistants later on. So once we do that, we are actually getting like 15 documents. For each document, we're actually splitting it in different parts. And that's why at the end, we're actually getting 67 items. Just to make sure we don't run 67 times the next node, we have to add another aggregate module here so that we aggregate the whole thing. And then what we're going to do is, again, we're going to search for the Google files, and we want to delete those files. So we go and use the same basically ID of the folder that we have right here. And I want to basically extract all the files that I have in this folder and delete those files just because I don't need them. Like, think about using this app many times for many clients, right? You don't need to consistently store the files for each and every client because you're never going to use them before. Once you updated your Pinecone vector store, you don't need to keep those files anymore. So we want to delete them because they're going to take space and they're not needed anymore. That's why here we actually retrieve all the files in the specific folder. And as you can see here, we got the 15 files. And then on this one, we're actually deleting all the files. So we're passing the AT and the files are deleted. And if I go to this page, as you can see, it's exactly the folder. It's completely empty just because all the files have been deleted. Again, we have deleted 15 files. So 15 operations actually passing to the next node. So we have to use another aggregate module. So we don't need that. And then we have an OpenAI model. An OpenAI model that we have here is actually doing the analysis itself. So it has the Pinecone vector store that we just updated with the data. It accesses this data to provide a structured output format on the key insights that we're looking to extract from this kind of company website. So again, let's actually take a look on this one. So I'm using 401 mini for this example. And if we go right here, we can see that it's quite a bigger prompt here. But the cool idea is that basically your task is analyzing complete content of a company website, which we provided to you through the website data tool. So it has the access to the data tool, and I explicitly say that. So there are some instructions as you can read through, pause and read if you wish. What is really important here, I ask it to do the JSON output structure in the following format. So based on the Pinecone vector store data, it will need to do the analysis and provide with the following insights. company foundation, problem solution, insights, marketing landscape, etc., etc. Just make sure we have a system prompt, and I don't have here the user prompt. We don't always need that. And just make sure you select output content as JSON. And also I have the temperature and top P set to 0.5, so there is like a little bit less hallucination in a sense. And what is more important, we have again the Pinecone vector database that is going to use as a tool. So to get additional information about your company and its website to generate response for a user. I have set a limit to 30 just because here we are actually having a lot of information to retrieve. And we need to make sure it has all that data in it. It's not just one chunks, but it's actually more. So it's about like 3,000 words in general that it can get as an additional context, but that should be enough for general idea. And actually, the reason I like this approach much more than just simply, dropping a link and etc., just because I have control of what kind of information is passed. And also using the vector database, I can semantically pretty quickly find the right information I need. Instead of just trying to, find the right information from the website, once it is stored in the vector database is pretty easily, because whatever we ask is actually right in. So we don't need to bother with that. So that's why here I have like a limit to 30. And once again, I'm using like text embedding 3 small model, 512 dimension. So this is what's going to happen right here, and then this guy is actually outputting me basically the information like this: the problem statement, product description, target audience, etc. So the last thing we need to do is basically create a Word document and store that information in the Word document. So here we're going to go and create that file, and the file name is going to be exactly the same as the URL of the company. That's what I prompted. And I have another Google Doc, basically FireCrawl final data. This is the place where the final kind of output is going to appear. And once we go there, basically this is the information to update the Google Docs. So once we go there, we basically say this is exactly the same file ID, and we want to pass this data. So the company URL, company foundation, product and solution, customer insights, all that we just pre-select from our OpenAI module that has done all the work based on the information we've gathered from the website and stored in our vector database. So that's basically it. That's how it works. And I think that's quite useful if ever you need that information to get ready for your client meetings, or just gather additional context about your company. That can be quite useful to use. As I said, the context is actually very, very important for any AI model. And as long as you can get the right context, the quality of your output will increase significantly. And that's it. Now you have an AI agent capable of instantly providing detailed context about any company you work with. Today we harnessed FireCrawl, Pinecone, and some other AI tools to revolutionize the way you gather business insights to improve your AI outputs. If you enjoyed today's tutorial, please hit that like button, subscribe, and ring the bell for more innovative AI solutions. Got questions or comments or your own insights, please drop them in the comments below. I always love hearing your feedback, and I always respond to your comments. Thanks for watching, and I'll see you in the next one.